Hi, good morning, and welcome to the ZP Developer Zone. So we like to do this Developer Zone every Thursday about 8 a.m. London time. Now today I've gone late, and it's because we're actually traveling. I'm in the USA, so my apologies for that. But that said, let me go forward quickly and be efficient with your time. So today's the 14th of March 2024. My apologies that we've gone slightly late today. Now at Zimmer Peacock, today I'll talk about pH sensors, I'll talk about screen printed electrodes, I'll talk about SenseItAll platform, I'll talk about immunosensors just very briefly, and HCG, which is the kind of hormone that's, it is unfortunately a marker, I think sometimes for cancers, but it's also a marker for pregnancy. Everything we do is really about turning electrodes, screen printed electrodes, into final assays. So we describe ourselves as kind of the field to cloud or the person to cloud platform. Now, as a platform, what I mean by that is as a company that everything we're about is actually, in the end, probably making a measurement, and that measurement actually going to a cloud database. Now, I know I said I was going to talk about screen printed electrodes, and definitely pH sensors as well. I just want to kind of bring this up as well. This is the SenseItAll platform. This is a lot of what we do ends up coming to the SenseItAll platform, because it's our quickest way of turning an idea into an actual tangible piece of hardware that can start making its way out into the world and actually impacting people's lives. So we're very keen on guiding people on how to use this platform and actually to sort of essentially commercialize their ideas. Well, that said, let me go forward a bit quicker. There is a SenseItAll webinar on the 26th of March, one in the morning and one in the afternoon. These are repeats. When I say morning, I'm talking this is in UK time. They're repeated just to simply cover the globe. So if you're in Europe, come to if you're in Asia, come to the morning one. If you're in Europe, the morning one works for you. If it's the afternoon and you're in Europe, the afternoon works for you. But the afternoon works for you quite well as well if you're out in California. So choose the webinar that works for you. If you see a link jump up, that link will take you to the registration page. We also do consulting. We come up site and we consult with people. We also run workshops at our place. So if you're interested in IVD, in vitro diagnostics, and CGM, continuous glucose monitoring, we do have workshops in Norway. We also come on site and do workshops for people, but you have to have enough people there to kind of determine that it's economically feasible. Questions today: how small can we make a pH sensor? So I will answer that pH sensor. They were also interested in the power requirements of that pH sensor as well. I'm not going to be able to directly answer it because the power requirement really depends on the electronics, but I will say that pH is probably one of the lowest powered systems out there. I always think when we look at the sort of the energy or the power balance of a system or a microfluidic, I shouldn't say microfluidic, of a sensing package, the sensing element itself is often the lowest power. It's always the communication that's the much higher power. I've got questions regarding the SenseItAll platform. The questions are around patient name, and the SenseItAll platform, you could put a patient name into this. I don't suggest that people necessarily do it because that's kind of, you're now stepping into patient confidentiality and stuff like that. ZP, when funded properly, will do programs where we are talking about secure databases that would hold patients' names, but now you're stepping into a whole area of security and proving to the FDA that these databases are compliant. That has to be well funded to do that. Questions regarding screen printed electrodes. Somebody's interested in something called the 501, which is a screen printed carbon electrode. I think their biggest problem with their current supply is that it's not repeatable, so I suggest they go to the 501. Questions regarding making an HCG test for pregnancy. So a lot will actually, I put this up here, but the first thing I'm going to talk to this morning about pH sensing. So how small can we make a pH sensor? And they've asked a question as well, because it's how small can you make the pH sensor? Therefore, how small can you make the connector? And by the way, what's the power requirement for a pH sensor? So I'm going to at least be able to answer the first of really those three questions. So this is the ZP hypervalue pH sensor. I just want to say that we don't actually need this electrode here. So the first thing is, I would recommend these people that they actually get hold of the standard product and they actually start, and they know that they only need these two electrodes here. You could essentially measure between these two electrodes here. We don't need this third electrode. I'm sort of suggesting that they actually start trimming away these areas. When I say trimming away, using a scalpel or using scissors and trimming away that material and testing as they trim. So essentially testing this pH sensing as they trim away. Because what I'm suggesting is that they can essentially they can determine what is the smallest area that we can get away with, and it will still function as a pH sensor. We haven't done this work at ZP, but I suspect that you can actually manually trim away a lot of this, let's say, electrode. I'm just sort of saying, and leave yourself with these very small black dot and silver dot. Leave yourself with those dots, at which point now I believe it would still function, but you would have to do that piece of science yourselves. So hopefully I have linked back to the pH sensor. I may have not, but what I'm suggesting is you get those pH sensors and you trim them away until actually you're just left with a very small sensing area, and make sure that it still works. So you only need to be connected with these 2 points here. We don't need this entire length, by the way. So if later on then you want to kind of have a sense of how small can I make a pH sensor, then I suggest that it's perfectly feasible to kind of have a sensor of this kind of 2 millimeters by 3 millimeters kind of area. The thing that I haven't addressed is your contact point. Now, our contacts are like this here. So I do understand it's quite large and bulky and you want to implant it. To be honest, you getting micro connectors is not a problem. There's a massive, thick catalogs of connectors. It's just I can't put an engineer onto it and start sort of scrolling through and looking at the pros and cons of it. It would have to be as part of a actual program. But the first part of your question is actually something that's easier to answer and something you could answer yourselves. You can also find those connectors yourselves as well. Just go through in like an RS, a Radio Shack catalog, obviously online these days, and find a small connector. The first part of your question is, I would actually get these hypervalue pH sensors and trim away lots of material, testing it as you go until you can no longer until you no longer get a decent pH sensor. I want to say the only electronics that ZP will support, well, you need another two things. You probably need some electronics from ZP. I understand these electronics are too big for your final application, but you've got to kind of walk before you can run. So I understand your final application will probably be quite small and implantable. But in the first instance, these are the electronics that we would support. And we would also get you to get the test solutions from ZP as well. Otherwise, people start bringing all sorts of bizarre pH solutions to these sensors. And you're dealing with two problems, the solutions themselves and the pH sensor. So in the first instance, we ask people, get the solutions from us, get the electronics from us, and I say that you trim that pH sensor until it no longer functions, and that will answer your question definitively, how small can a pH sensor end up being? Question number two, right, so with question number two, we do a lot of this. Somebody has an idea, so you have an idea. The problem with an idea is it's not tangible enough for most investors. So if we think that the idea suits the platform, we have a SenseItAll platform. This is described as an OEM platform, an original equipment manufacturing platform. It works with our screen-printed electrodes, but we also have turned these screen-printed electrodes into biosensors. There's a whole bunch of biosensors on the ZP platform, or we've developed an assay. But in the end, the investor would be sort of looking at something that looks like this. So the first question is, and I just want to say, if you're using an iPhone or an Android and you're watching this on another screen, it's good because you can use your QR code in a minute to sort of practice a little bit and see what the workflow is like. Does the device have a way to type in the name of the patient being tested? Yes, it does. Please, I know these people have come to the webinar in the past. So we do a live webinar. The next one's on the 26th of March. Come along again to it. Because when we do those demonstrations, you'll see our engineers put in a test ID. You can put in a patient name once you start doing that, you're getting into all sorts of legalities with putting patient ID. So I'd actually suggest that when you're doing your alpha testing, your beta testing, your preclinical testing, you don't necessarily put patient names into it, because now you're putting patient identifiers into the clouds, and you've got to kind of be registered for that. What people do with us actually is they'll put a test ID, they'll have a register of test ID and name, but they're not putting that in. They're putting the test ID into the device, not the patient's name itself. But you can, is the answer, put the patient ID in there, but you're the ones who've got to really either have funded us properly so that we can sort of take care of it, or you've got to take the legal responsibility if you put in patient names into that. The device does not have a screen on it as standard. We do a lot of contract development, contract manufacturing with people where we do put screens on devices. The screen for this device is the in fact, you could say it's got a device, because you could just give it a dedicated Android, and that is, so this is the what's going on here is actually the screen for the device, because it's making a Bluetooth connection with the smart phone. If you want to check that out, get ready with your phone to scan some codes. Can the results and the name of the tested be uploaded to the cloud, Wi-Fi or Bluetooth? So a lot of people with these smart devices these days, we have a data plan on that. We either have a data plan or it's connected to the local Wi-Fi. So this phone's connected to the local Wi-Fi. So this device gathers the data. It's in Bluetooth connection with this device. This device, once the data comes across by Bluetooth, then this device sends the data to the cloud, either via the data plan or via the Wi-Fi connection to the local Wi-Fi. But the quick answer is the data always goes to the cloud. And yes, you will be able to access the historical data. So if you have a clinical study and you have 20 patients come in, and you put every time a patient comes in, you put a test ID, you run the assay, the data, they'll get a result on the phone, and the data goes to the cloud, and you'll be able to historically get it. This is fundamental to what the whole platform is about. So let me just describe that again. I would say, I know you've been to that webinar last month. I would suggest coming to the webinar again on the 26th of March as well. Just to say, the 26th of March, not some magic number. We do these webinars at the end of every month. So if you see a link today underneath this video, just click it and it'll take you to the next one, the next webinar that we're having. So you've got the sensor, you've got a QR code that tells the meter what to do, you've got the meter, you've got the app installed on your phone. This is the cloud database. You put the sensor into the meter, you put the patient sample on the sensor. The app will ask for the test ID. You could put the patient name in there if you so wished. The meter will run. The data via Bluetooth will go back to the app, and the app will upload the data either via the smart device Wi-Fi connection or via the smart device's data plan. So it's going over the kind of 5G or 4G network. At which point you do get a result on the phone, on the screen, if you want to call it that. The reason I can't say screen is people don't have to use their own phones. You could be sending out a dedicated Android or Apple pad with it. So people are using a dedicated device, so you could call that the screen. As it is, they get a result there and then. And then the test ID, if you want to call it patient name, and the raw data all goes to the clouds, and it can be along with the result, and that can all be found later on. You can then decide to share it with people like ZP if we're actually helping you to troubleshoot the assay as well. And then there's something called an API, an application program interface. This is what I think, that is, in fact, people will develop patient care portals, and the SenseItAll platform will be part of that. But in the end, there'll be a patient care portal where you have lots of data coming in, and so you can have data coming in from our cloud via what's called an API, an application program interface. We can kind of go through this stuff when people are actually clients, and we can sort of train them on what APIs, etc. I mean, people do know what APIs, application program interfaces, but if you're not so sure, then we are technologists, and we can take you through this. If you haven't done this already and you have an Android phone, please scan this QR code. So Android phone users, please scan this QR code. iPhone users, please scan this code. And then just to experiment, here's an assay to experiment on. The SenseItAll is a multi-analyte platform. For every analyte that we have on the platform, we have a QR code. If you want to see more QR codes, please come to the webinar on the 26th of March. Otherwise, just experimenting now. Here's a glucose QR code. So you install the app using the previous two. So for Android users, use this app to install the SenseItAll app. For Apple users, use this app. And once that's installed, the next thing it'll ask you for is what assay do you want to run? And here's a quick QR code to show you a glucose assay. Question number 3, do we have a detailed schematic of the 501 electrodes? We do. And I realized that these people were really interested in repeatability, and I did send them some repeatability data, and I haven't included it in this webinar today. Biggest problem in biosensor development, I get it all the time. It's actually repeatability of screen printed electrodes. And these are not the repeatability of ZP screen printed electrodes. As soon as people have used ZP screen printed electrodes, they actually completely say these are the most repeatable electrodes. You know, they are the most repeatable electrodes. Why are ZP electrodes so repeatable? Because we put a lot of effort into making them repeatable. We test all the batches to make sure that they're repeatable before they send. Why do we care so much? Because we use these sensors in our own products. We're the only ones screen printing like this that are using the sensors in our own products. You know, we have to have repeatable electrodes so that we make good products. And then, by the way, we sell them on the web store for use by startups and academic communities. But understand, it's a different philosophy. We need them to be repeatable. They are repeatable. And I was able to show these people the data. We do have the data on YouTube and on our website. But anyway, they had 2 questions. They wanted to have a more detailed schematic of the 501, and they're also using a particular potentiostat that has what we call LEMO connectors. And at the other end of those LEMO connectors, I know that the banana plugs would be 2 millimeters. So I'm just recommending a connector for you. There's a very popular brand of very small potentiostats out there that use banana plugs. The banana plugs are 2 millimeters. If you want to use that potentiostat in connection with ZP's screen printed electrodes, then you'll need this connector, and I'm just going to give you some links to that now. In fact, so here's the 501, here's the link to the 501, this is what the 501 looks like, and here's the data sheet here. So this green arrow is pointing where that data sheet is so they can find that. In fact, I have linked to reproducibility, so I feel a bit ranty, but rant. These screen printed electrodes from ZP are really reproducible. They have to be really reproducible because we're using them in our products. If you're unsure about it, come to the webinar on the 26th of March and you'll see evidence of the repeatability. You'll also find evidence here. There's a link here. I'll put it underneath the video. Please click that and it will give you evidence of our repeatability. I'm also, some companies, we've been talking to them since like 2018, 2019, and they're not on the market. So this is why we have technology like this. People who are able to be flexible, pivot, and people have a very kind of certain way that they want their assay to work or think that their assay should work, which is often quite more complicated than it needs to be. The good thing about working with ZP is that we're very experienced at making things as simple as they can be in order that people can get to market as quickly as possible. So I'm suggesting that even with these guys, come to the webinar on the 26th of March and see how we can get people. We kind of got this 2-year manifesto. I need to check the spelling on 2-year. But we think or know that we can get people to market in 2 years, much shorter than the 5 to 15 years that most people take, and actually only 10% of them are ever successful. Somebody is interested in developing an HCG test for pregnancy. I do say to people, don't use gold electrodes. Even though these are our gold electrodes, I actually say to people, use carbon electrodes, and we've actually been successful in making HCG assays on top of carbon electrodes. And if they take my advice and use the 501 or the hypervalue carbon electrodes, then they can then use it with this platform. And to be frank, they just went from idea to something very tangible very quickly. If you think you're going to do immunoassays or molecular assays and you think that you need to be using gold, you don't need to be using gold. It's just there's a lot of literature out there that suggests gold. Carbon is a much more commercially viable option than gold. Gold, there's a lot of precedents for the kind of chemistry, biochemistry. There is also precedents for how to use carbon as well. If you've got a choice, you use carbon. It's just a tenth of the price of gold. It's the same for platinum as well. If you can avoid platinum, avoid it. It's super expensive. So don't forget, we've got this live webinar on the SenseItAll on the 26th of March. I hope some of you come. Just choose one of the sessions that's most convenient to your time zone. I'll put a link here. I know it says January there, but we keep updating the content on that page, and so every month for the next webinar, we update the registration there. So I just want to say thank you. If you've got any questions, don't hesitate to contact us at zimmerpeacock/contact, and thank you very much. All right, take care. Have a good day. Thank you.